Welcome to the lecture on simulation examples. So, in the last lectures we had the introduction about the different kinds of problems involving these simulation of discrete systems, and we discussed about the concept of model, system and simulation. We also saw the applications and advantages and disadvantages of these simulations. So, we will discuss that how we come across certain examples where this concept of simulation is used, and earlier we have also discussed about the applications. So, what we have so far discussed that we have the application of simulation in normally these areas like queuing system, inventory system, reliability problems, scheduling problems, logistics in military sectors, etc. So, what we have understood with the concept of discrete event system simulation is that normally the process is stochastic, there is randomness, we do not know that what is to be when the things will happen, when the event will occur. So, there are random components, and that is why you have the generation of random numbers many a times. In these cases, about them basically we will discuss in more detail in our later chapters or later lectures, but we will see that how these random numbers are used for solving such problems in the cases of queuing. Like in queuing, what we have earlier studied also or earlier discussed, that as we take any example of practical example of queuing problems, the problem is that we have to predict first that when somebody is going to come, then how much time he is going to be in the queue, then how much time he is going to take for getting the service, and then when he is going out. So, these are the components which are basically random components. About them the prediction is done, and since there is probabilistic component involved, so we use these random numbers. There are many kinds of density functions or distribution functions that we will start in our next lecture. So, there once we get that, then we will have a chart and we can predict based on the past observations that it is likely that the customer is going to come at a particular time. When he comes, then the server is going to be either idle or it will be engaged, and then it will also take some amount of time, that is again probabilistic, to be served. So, that is service time. So, based on that the queuing performance measures can be estimated, like average time spent in the queue, average idle time of the server, all that. Similarly, in inventory system, as we know, in inventory system you have basically to order the inventories. So, how much to order, what will be the demand on a particular day, these are the probabilistic components, and these things are basically coming from the past data. So, depending upon the past data we are generating it, and in generating that in fact the random numbers are very much used. So, we will discuss about one of the problem like in queuing system, and then also we will discuss in brief about other systems like in inventory again. So, let us go to one problem of queuing. Now, let us see, there is a queuing system example like at a grocery store with one counter, customers arrive at random from 1 to 8 minutes apart. So, what we see is that we have a grocery store and customers are coming randomly from 1 to 8 minutes apart. So, that is given inter arrival time. One customer is coming, so and after that the next customer will come. In between them the time of apart may be 1 minute, 2, 3, 4, 5, 6, 7 or 8 minutes. So, there are 8 values. Now, that is each of inter arrival time has the same probability of occurrence. It means the probability of having 1 minute is 12.5%. Similarly, probability of having 2 minutes is also 12.5%. So, they have the equal probability. The service times vary from 1 to 6 minutes with the probabilities as 0.10, 0.20, 0.30, 0.25, 0.10 and 0.05 for 1 to 6 minutes respectively. So, for 1 minute the probability is 0.10, 10% probability is there that the first person who will get service will have 10% probability of 1 minute. Similarly, 20% probability is there that he will be served in 2 minutes, 30% probability is there that he will be served in 3 minutes, 25% probability is there that he will be served in 4 minutes, 10% probability is there that he will be served in 5 minutes, and 5% probability is there that he will be served in suppose 6 minutes. So, these are the random components, the probabilistic components given to you, and based on that you have to simulate. So, you have to analyze the system by simulating the arrival and service of 20 customers. So, how we do, how the simulation is carried out, for that we will have an idea that how this simulation will proceed. So, what we see is, now in this case as we have understood that you have arrival time is given, inter arrival time is given, and you have the service time given, and for that you have to assign the random digits. Now, in this case basically these random digits are given, these random digits can be produced. So, you have softwares by which you can produce the random numbers, you have the methods by which you can produce the random numbers. This we will discuss in our later chapters, but here for example, we have been given that this is how you are going to use the random numbers for the inter arrival time. Now, how to interpret that? So, what we have seen, we have known that this inter arrival time varies from 1 to 8. So, you have 1, 2, 3, 4, 5, 6, 7 and 8. So, these are the 8 values of inter arrival time. Now, what we see is that its probability of each component each time is probability is 1 by 8. So, probability is 0.125 for each one. Now, this is the probability for each of the component. The practice is that you have to assign the random numbers in such a way that if the random number is chosen, they have equal probability that it will be among any of these. So, the practice is that you have a set of random numbers, you have the numbers in a certain domain or in a certain range, and in that you assign these numbers. So, suppose what you do for them is, it is better since it is by 8. So, it is better we can take the random numbers up to 8 or in a multiple of 8. So, but then normally the better practice is to take the random numbers from 1 to 100 or 1 to 1000 or so. So, being multiple of 8, so 1000 is the multiple of 8. So, we are taking the random numbers from 1 to 1000, and in that case and then we are basically distributing them. So, if we are taking the random number range from 001 to 000. So, basically before that you have 999. So, altogether you have 1000 numbers. So, in this case what is seen is, now in this case you have, so if you take random number random number 001 to 0, so to 1 to 5, this will be for 1. So, this number will be, so if the random number which comes while doing the simulation, if the first number is in this range 1 to 125, then the service, the inter-arrival time will be taken as 1 minute. So, this is in the minute. So, similarly it will go further 126 to 250, then 251 to 375, then 376 to 500, then 501 to 625, then 626 to 750, 751 to 875, and 876 to many a times you start here from 000 and you end to 999. So, either that convention is followed or this convention is followed, any of the convention may be followed. So, here we start from 001, so we will end with 1000. So, going to 4 digit, we do not go to 4 digit, we take this digit. So, this digit may be taken as the equivalent to 1000. So, that if that value comes, it will be corresponding to 8 minutes. So, what we see is, in this case if we see the first customer, since first customer is coming at 0 time, so there is no random digit assigned. Coming to second customer, so customer number, if you look at customer number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So, you have these customer numbers, and as you know that your random number is given for inter-arrival time is 913. For first there is nothing, because first is coming at 0 time. So, here that is determined. So, second the random number is 913. So, inter-arrival time. Now, inter-arrival time, if you look at the 913, the first random number which is there in the table, according to that 913 comes here. So, it means the inter-arrival time is 8. For second, it means the first customer comes at 0 time, the second customer will come 8 minutes after the arrival of the first customer. Similarly, you have 727. So, 727 comes in this range and that will be 6 minutes. Then you have 015, 948, 309, 015, 948, 309, and further you have 922, 753, 235, 302, like that it will move. So, for fourth it is 015, 015 will come in this range and time will be 1 minute. 948 will be again in this range, so time will be 8 minutes. 309 will be in this range, it will be 3 minutes. 922 will be again 8 minutes. 753 will be again here 7 minutes. 235 will be in this range, it will be 2 minutes. 302 will be in this, so 3 minutes, like that. So, then for 11 to 20, 109, 093, then you have 607, 738. So, like that, if the time we have, we can solve that, but we can have the idea, that idea should be clear from here. Similarly, so this way you have these inter-arrival times defined with you. Now, let us go to the next, the service time. So, this random number is for inter-arrival time. Then another set of number is random number for service time. This number is also given to you. Now, this random number for service time is given. Now, for service time, if you look at, so this was for the inter-arrival time. So, this random number was for inter-arrival time. Now, for service time we have been given the probability. For service time, as we see, we have been given the probability of 10%, 20, 30, 25, 10 and 0.5. So, this random number can be assigned from 1 to 100. So, we can start from 01 to 00, like that. So, in this case, if suppose if we go for, so for customer, if we take the service time, we have 6 values, 1, 2, 3, 4, 5 and 6. The probability values are given as 10, 20, 30, and then 25, 10 and 0.5%. So, the random number for service time will be again assigned based on that. So, for this you can have the random number range from 1 to 100. So, we can have start from 01 and it will go up to 00. So, for this it will be 01 to 10. Similarly, it will be. So, what we do in normally is we get the cumulative probability. So, based on that we can get it anyway. So, it will be 30. So, it will be from 11 to 30, because this is 20%. So, after this you have to have 20 numbers. So, this will be 11 to 30, then if further it is 30. So, it will be 31 to 60, then you have 61 to 85, then 86 to 95 and 96 to 00. So, this way you can have the numbers which is assigned, random number assigns for the service time. So, what we see here is you have different random digits for service time, and these digits are like 84, 10, 74, 53, 84. So, here for first also it will come, for first it is 84, then you have 10, 74, 53, 10, 74, 53, further you have 17, 79, 91, and then you have 67, 89, 38. So, let us see how we do in this range. Now, in this range, as we know, the service time which will be approximated or which will be predicted by using these random numbers will be again based on this table. So, if you have service time of 84, it means 84 is coming in this range, and the service time which is expected of the first customer is 4 minutes. Similarly, the second number is 10, this 10 is coming here, so it will be 1 minute. 74 is coming here, so we can take it as 4 minutes. Similarly, 53 you will have here 3 minutes, 17 is 2 minutes, 79 you have here 4 minutes, 91 is here 5 minutes, 67 is here 4 minutes, 89 will be coming here as 5 minutes, and 38 will be here 3 minutes. So, this will go further. You have another numbers written like 32, 94, 79. Like that. So, you can have the prediction of these random numbers. So, what we know, by this time we are knowing that when the customers are coming and how much time they are going to take for getting the service. So, in how much time the server will be serving them, that is the service time. So, once you have these two components known, then you can find other measures of performances like how much the customer has waited in the queue, how much the customer has waited in the system, for how much time the server was idle. Now, let us see how this table is made. So, that is known as a simulation table. This simulation table is like this, where you have first you have the customer. So, customer in that table you will have 1 to 20. So, if we try to see, we can have certain idea that how we will proceed in this case. So, let us say you have the customer. So, customer number will move from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and then it will move. Inter-arrival time already it is predicted. So, the first one is inter-arrival time. First one is coming anyway at 0. For the second one it is 8, 6, 1. So, it is going like that 8, 6, 1, then 8, 3, 8, 7, 2 and 3. So, we are just limiting our studies to 10 persons. Then in that case, if suppose it is at time, the time at which the customer comes. So, what we see is time at which customer arrives. So, the arrival time of the customer, if it is 0, it will be 8, because there is 8 minutes of inter-arrival time between the first and the second customer. So, first customer comes at 0 time, and for him the inter-arrival time is 8. So, you have 8, then similarly it will go to 14, 15, 23, 26, 34, 41, 43, 46, like that. So, whatever number comes here, in that case you can have the arrival time. Next is service time. The service time, if you look at, the service time again is the probabilistic component which we have predicted from the random number generation. So, here what we see is 4 1 4 3 2. So, for first it is 4 1 4 3 2, then you have 4 5 4 5 3, and then it will move. So, this is the service time. Now, what we see is this customer, next table is time service begins. If you look at the time at which the service begins. So, the customer has come at 0 time and it has taken 4 minutes. So, time service begin, anyway he is coming at 0 time and the server is free. So, he will start his service at time 0. Then once he has started at time 0, the second customer, because he will take 4 minutes, it will be taken 4 minutes. After 4 minutes, this customer will depart. So, after 4 minutes this server is ready to further serve. Then waiting time in queue. Next is time service ends. Further, you have time customer spends in system. And the last is idle time of server. Now, we have few things. Two of the parameters we have basically predicted. One was inter-arrival time and service time. So, inter-arrival time we got from here and service time we have got from here. Now, from here, by looking at the problem, we can fill all these data. So, depending upon the cases, you will have all these data filled. You can have the waiting time in queue. So, based on that, a person, so you can have the average waiting time in the queue. So, once you get for 20 customers, you can have the data here, and then whatever summation comes, based on that the average waiting time in queue can be found. Similarly, you have the idle time. Now, for how much time? When the customer comes, when he goes into the queue, and when the next customer goes of the service, depending upon that the idle time of server can be calculated from this table. So, this can be practiced and you can get the results. These results, whatever you get here, based on that the percentage of the time the server is idle, that can be found out. So, what I mean to say, that our main job was to predict this and this. Based on that you can have all these data, because when the service will begin, certainly when the customer will leave, the next customer will join the service. So, that way service will be coming. Based on that you can have the waiting time in queue. When the customer joins, if we add the service time, then the time service ends, that can be found. So, this way all these values can be filled in, and once you fill that, then after that all the measures of performances can be found out. So, this is how we solve such problems in the case of queuing. Coming to other problems like in suppose inventory, there will be probabilistic demand. So, again demand will have a probabilistic component. It may be said that the demand may vary from 100 to 150. So, again that may be based on the random number generations, and in the similar way the random number can be generated and demand can be predicted. So, maybe in future we can solve such problems when we discuss about these problems typically, and one by one we will try to solve such problems when we discuss about the queuing cases. So, such type of example problems are expected in case of simulation. Thank you.